Hello guys. Today is a bit dark because I got my friend sleeping right there. You cannot see him, but he is behind the chair. But today is day 24. Yesterday I didn't do shit. Because yesterday is my birthday, my guy. And I'm having fun, you know? But today we're going to start learning again. New experience. It's day 24. And I'm gonna learn camera manipulation. 1, 2, 3, 4, 5, 6. 6 more, guys. 6 more! We finished this today. Let's go. What the hell is that more, man? What the? Stop. So that's not good. Okay, that's not good.
Thanks for stopping by, everyone. I just hate these round-based games that make you have to wait until the next game starts when you go into the game. But at least this game has a spectating mode, so I'm just gonna click on this and see what's happening. Wait, Newbert? Who is this random shadow man standing right behind you? He looks a little creepy. Like, are you not phased at all, Newbert? Who am I kidding? Newbert just has his AirPods and he can't even hear or see what's happening. Newbert, I think you should turn around. I don't want you getting killed. Wait, Newbert, he's not Newbert! He's got his AirPods, he can't hear me! No! Newbert! No! Whatever. At least I can play the next game now, that's all that matters. Alright, let's think about this for a minute. This video is going to be about camera manipulation, which is based off of the idea of our camera object. Now, our camera is what allows us to view the 3D world in its simplest definition. And there are ways that we can manipulate this camera through changing the properties and through scripting as well, which is what I'm going to be teaching you how to do inside of this episode. So from this example that you saw here, when I press the spectate button, it moves the camera to this specific position right here to be in front of Newbert. And another example that I've created is we can hold left shift to sprint, and that is going to zoom our camera outward just a little bit. And if I let go, then it's going to zoom the camera back in. So this is manipulating the way that we move our camera through scripting. If let's sprint, and that is going to zoom our camera outward just a little bit. And if I let go, then it's going to zoom the camera back in. So this is manipulating the way that we move our camera through scripting. If let's say we had a system like this in place. And so these are just some examples of being able to manipulate the camera, and that's what we're going to be doing inside this video. So with that being said, let's go ahead and go straight into the episode.
Camera manipulation. Too bright, my guy. It's too bright. Need to make the brightness lower. It's just enough brightness.
Now that we understand it, let's implement camera manipulation inside Roblox Studio. But I do want to emphasize that when we're changing the camera, either through its properties or through scripting, we want to do it on the local side because every single player has their own camera, since what they see in the world is going to be unique from each other. So we're going to get into more about that later when we start scripting it. But as of right now, what I want to do is introduce to you some properties that we can change with the camera. And the first place to look is inside of Start Player. So just like this.
Wait. Chill.
That when we're changing the camera, either through its properties or through scripting, we want to do it on the local side because every single player has their own camera, since what they see in the world.
Okay, need the camera in the local side.
Is going to be unique from each other. So we're going to get into more about that later when we start scripting it. But as of right now, what I want to do is introduce to you some properties that we can change with the camera. And the first place to look is inside of Start Player. So just like this.
Wait, I didn't like fix my setup yet. Just cannot see anything. It's fine. It's fine. You guys don't need to see me, right?
And there should be a category called camera right over here that has these properties that we can change for a starting player when they join the game. So I'm just going to scale this out so we can show the properties. Two of these involve the zoom distance for the camera. So basically, how far away can the player zoom and how close in can they zoom? So by default, the max zoom distance is 128. So if I were to demonstrate this to you, I can just reduce this to let's say 20, and I can increase the minimum zoom distance to let's say 10. So now if I hit play, then what should happen is that if I try to zoom out, it's not going to work because I set the max zoom distance to 20 studs. Now if I try zooming in, it's only going to go in as close as 10 studs from the player. So it kind of gives a constraint to how far the distances are with the camera. And so that's one set of properties. So I'm just going to hit backspace and just hit back.
Max zoom. What? How much is like 128, man? Is zoom out, that is zoom in. Okay. Let's try like 500. What will that do? Is that like zoom out? Oh, okay, I see. That's zooming out. Oh, so to make the zoom in to become like 5, so I cannot zoom into the head. Oh, that's cool. That's cool. Okay.
Backspace really quick. Next thing is camera mode. So there's only two options: inside classic or lock first person. I think that was pretty self-explanatory. Now, dev camera occlusion mode is essentially a way for the camera to handle objects that are obstructing the character with the camera's view. So if I were to create a part just like this, I'm just going to create like some occlusion mode is essentially a way for the camera to handle objects that are obstructing the character with the camera's view. So if I were to create a part just like this, I'm just going to create like some tall structure right here. And what I'm essentially going to do is hit play. So what's going to happen is when the camera tries to deal with objects that are obstructing the player like this, then it's going to zoom the camera into where the player is just like this. I think you kind of notice what's happening here. So this is what's happening by default, but there's actually a second option we can change for the.
That's cool. Oh, I see.
the occlusion mode, and that's called Invisicam. So when I hit play now, once we go into the game, then instead of zooming into the character, what it's going to do is it's going to set the transparency of the object.
Oh, I think I like the transparency more, man. It's up to choice, right? It's up to choice because like when I play, I don't want to get my camera like. Oh, okay. Understand. I don't know which one I like more, but I think I like this more.
Objects that's blocking the player to semi-transparent, or like 0.5 or whatever you want to describe this as. So that's what Invisicam does. And so I think this is something you should experiment with, depending on the kind of game that you're creating. Now there's two more options here, which is basically what allows the developer to set a fixed camera movement type for the user if they join the game. I'm going to explain these camera types in a little bit, but that's essentially some of the properties that we can set for a starting player. Okay, but now I want to get into the camera object itself, and this is located inside of workspace. So if I open this up, then our camera should be right over here. And there's two properties that I want to look at that are going to be important. One of them being camera subject, and the other one being camera type, which is both under the camera category. So to explain what camera type is, I'm just going to hit test and hit play, and it's basically a property that allows us to change what kind of camera that we have going for this specific player, or ideally for all players that are inside the game. So by default, it's set to custom, which is essentially whatever we pick for the camera mode that's inside our settings, which by default is classic. So classic is what allows us to move around freely. This is what the classic camera type is. But then we can change this to something else, like let's say attach. So the way this camera goes is different than what we had before. And if I were to do fixed, then it's just going to stay in place. And then if we select something else, like orbital, then it's going to have this weird like top-down perspective. So you can see all these different types of cameras that we have for our game. And depending on the kind of game they're creating, I think picking one of these camera types is going to be pretty beneficial. So that's something I wanted to show. So I'm just going to quickly set this back to custom. And the other property is called camera subject. Now by default, our camera subject is the humanoid of our local.
Oh, hi. This feels really weird, man. Oh, this feels so weird. How about custom? How about fix? What about follow? What? Why it change by itself? Oh, so fix is. Oh, it can on. Oh, you can. Oh, this is like for camera. Oh, this. Okay. So let's like try everything. Okay, attach is like attached to the player, right? It attached to the player. You cannot move it. Oh, you can move it up and down, but it is attached to the player. Custom is like. Wait, what the hell is that even? Yeah, custom is this. Custom is the one that you usually do. And then fix is like when you're trying to. Yeah, this is like a camera. If you have a camera, then this is the camera right now. Cannot move it. You can move your character, but you can move this. Oh, okay, that's cool. How about follow? Oh, it always follows the player. Doesn't matter where you go. Oh, what's the difference with the custom one? I wanna know. The custom one is like it still follow you, right? Wait, what? I think there is some difference. Like follow, yeah, it literally follows you. Like I zoom in. Oh, okay. Or orbital is you can only see like this is like custom, but you cannot go up and down. Only like on the orbit. Oh, there is a camera subject. Oh, you can make a subject. The camera is from the. Oh. I know now. I know. So the camera's subject is the humanoid. So if we make a camera subject to a part, like we can make it like from, right? Like is there like a camera type that is straight from the thingy? Scriptable is simply scriptable, right? Like it's cannot move, you cannot do anything. you need to script it, right? And then there is track. What is this? I don't understand. Thing is, I don't know what that is. Track. Okay, I don't know what track is. Fine. And watch. Oh, it's from this one angle. You cannot zoom in or zoom out, but from this specific angle, you can watch, right? Like from this. Oh, watch is like for the. Oh, if there is a player, then this is like a automatic camera. Oh, the watch is like here. You cannot. You can still move. You can still move around though. Okay. Now it bugs. Okay, that's cool. That's cool. Now I know what that is.
Player. So basically, the subject is essentially the reference part or instance that the camera is attached to. So we can actually change this to be a reference to a different part by simply going to our camera, clicking on camera subject, and then we can select whatever reference we want for our camera subject. So let's say we want it to be the part that we created. So the camera has now moved to be the camera for this part that we created, because this is now our reference point rather than our character. So that's something I want to show as well. And if we want to revert this back, I'm just simply going to say camera subject, and then I'm going to click back on humanoid, so that we now have our reference being our character. So with what we know right now, we can start scripting our camera. And what we're going to do is create a local script in, let's say, starter player and starter player scripts. We're going to hit the plus sign, and we're going to insert a local script, and we're going to delete this code right here. So the first thing we have to do is make reference to our camera by saying local camera equals game.workspace.camera. Now you might think that this is the camera that we're trying to reference here, but that's actually not correct. Even though there is a camera inside Workspace, this is not the right kind of camera that we want to manipulate, because there's a difference between a camera and a current camera. Camera is basically the studio's camera, but what we want to manipulate is the current camera, which is basically our local player's camera. So instead of camera, we're going to say current camera, just like this. Even though there is a camera inside Workspace, this is not the right kind of camera that we want to manipulate, because there's a difference between a camera and a current camera. Camera is basically the studio's camera, but what we want to manipulate is the current camera, which is basically our local player's camera. So instead of camera, we're going to say current camera, just like this. And so when we're manipulating the camera inside a local script, we want to use current camera.
Camera.
Okay, so now we have that. What we can do is manipulate a property that camera might have, let's say the C frame of it, and when we change the C frame of the camera, it's literally going to move the camera in a specific point inside of the game. So what we can do is say camera.cframe equals, and we just create a new C frame. We can say cframe.new, and close parentheses, we just say 100, 100, 100. So you might think that this would work, but let me show you what happens if we hit play. So I'm going to go to test and hit play, and what we should see is the game is still running basically as expected without executing the script, it seems like. But the problem that lies here is this code actually did run, but the thing is, Roblox's default camera system overrode this command that we created here. And so what we need to do is not have Roblox's default camera system override our scripts when we make modifications to the camera. And so what we need to do is set the camera type to scriptable. So if you remember for the camera, there's a property here for camera.
Mhm. Wait, what? Chill, 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 chill. We chill. There's a local script here, and then the camera. Need to make the camera subject to the humanoid.
type and script item. But the thing is, Roblox's default is the game is still running basically as expected without executing the script, it seems like.
Wait, what? Nothing really changed.
But the problem that lies here is this code actually did run, but the thing is, when we make modifications to the camera. And so what we need to do is set the camera type to scriptable. So if you remember for the camera, there was a property here for camera type, and scriptable was actually one of them. So this is what we need to set the camera type to before we make any scripting changes to the camera. So what we're going to do is hit stop. I'm going to go to the local script, and before we make the C-frame change, what we're going to do is say camera.camera type equals, in quotations, we're going to say scriptable.
Oh, this is the studio camera. Okay.
Just like this. And I'm also going to add a task.wait for about 1 second so that the game loads in time before we make this change. So now we go to the
Oh. Oh. Oh, I understand. I understand.
game and hit play. And what we should see is that our camera's C-frame is now located at the coordinates 100, 100, and 100 with X, Y, and Z respectively. But we haven't changed like the angle of it or like where we're looking at in specific. But this is essentially how we change the position of the camera inside the game once we change the camera type to be scriptable. So let's say we wanted to have a cutscene system where we have one starting point and one ending point for the camera to essentially go from the starting point to the ending point. We can do that by manipulating the C-frame of the camera using our scriptable camera type. And so what we can do is essentially create 2 points that go from point A to point B by simply just going to model. I'm just going to insert a part over here. I'm going to call this start, and then I'm going to duplicate this and then move this. Somewhere that's semi far away. I'm also going to change the rotation of this just a little bit, and I'm going to rename this one to end. And so what we can do is have our camera's C-frame start here, and then we can have the camera move into the direction of where the end part is over here. And so that way we can create this sort of cinematic experience by going from the first part to the next part. So what we're going to do inside the local script is reference these 2 parts by dropping 2 lines, and we're going to say local start equals game.works. Workspace colon wait for child open close parentheses start, and then we're going to do the same thing for the end by saying local end equals game.workspace colon wait for child open close parentheses end. Now I realize that Roblox is triggering a keyword here, so I think we should say end part and start part instead of just start and end, just like that. So now what we're going to do is change the C-frame of this camera to be the C-frame of the start part. So we're going to say start part.C-frame. And then what we can do is play task.wait for about 2 seconds, and then we can say camera.C-frame equals end part.C-frame. So if we go into the game, hit test and hit play, then it's going to start and do is play task.wait for about 2 seconds, and then we can say camera.cframe equals
Mhm. Mhm.
end part.cframe. So if we go into the game, hit test and hit play, then it's going to start at this part, like the start part C frame, and then it's going to go to the end part C frame just like that. But it didn't do it in smooth fashion. Like we literally hard coded the C frame to change after about like 2 seconds. But what we can do is add a smooth transition with tween surface. So what we can do is drop 2 lines above here.
Okay, I'm gonna try to make it by myself. Twin surface, okay. What we need to with twin surface is like twin info. Info.new. Okay, first we want it to be like 2 seconds, and we want the easing style to be like linear. Num.easing style. Okay, remember twinning surface. You just need to think, right? You just need this, and then we need a goal. Local goal, twin goal equals keyframe equals and part.cframe. Yeah, that's true. That's true. This is a twin goal, right? And then how do I start? Oh, I make the twin first. Then surface that create. So I add the camera and the twin info and then the twin goal. Now we twin dot play, right? Camera, twin info, twin goal. This is the end part. The start. So before we play the twin, um, camera C frame should be in the start part first. And then we need to make the camera scriptable, of course. Let's like put it up here. Camera C frame start part. Let's make this and let's do that. Let's try. Mhm.
And say local tween service equals game colon get service tween service. And then what we can do is instead of directly changing the C frame just like this, I'm just going to comment this out. I'm going to create a tween and then play it by saying tween service colon create open close parentheses, and then we're going to set camera as our object, and then we're going to add a tween info object. So we're going to create one here by saying tween info.new open close parentheses. We're going to make this last for 2 seconds, and then we're going to have a table full of the goals that we're trying to accomplish with this tween, which in this case is going to be the C frame. So we're going to set this equal to end part.cframe just like that, and then we're going to play this tween by saying colon play open close parentheses. By the end of it, we can even get rid of these 2 lines as well. We don't really need them. And now if we go into the game and play, then what we should see is that it did a little smooth transition between service by having the starting point go to rid of these 2 lines as well. We don't really need them. And now if we go into the game and play, then what we should see is that it did a little smooth
Yeah, the camera is
play
not.
open close parentheses by the end of it. We can even get rid of these 2 lines as well. We don't really need them. And now if we go into the game and play, what we should see is that it did a little smooth transition between servers by having the starting point go to the ending point just like that. I can even show it to you again by waiting for 2 seconds before the script fires. So 2 seconds have passed, and it went from the starting point to its ending point. And so that is essentially how we create this.
Wait, what? In what in what sense does it rotate? Like, I mean, like, in what direction does it see, man? I need to know this. I need to know this. Like, in what direction does it see? This is the end. This is the position. This is the C frame. This is so looking there, right? Looking there is going forward on the X value. Yeah, it is going forward on the X value. Let's see. Oh, it's looking forward at the X value. Oh, it's looking forward in the X value. I see. So if I rotate it right like that, it will look. Oh, I understand. I understand. So it looks at the X value. So if we want to make it go there, we put the we put like the C frame, like the X value. This is like the X value, right? This is what makes it the position. This is what makes the position. Like it starts. It look at there. It look at there. It start from looking at there, and then it like goes back. I think that's too fast. I need to slow down the twin. I need to see what's happening. And let's make tux.way to 2. Can test it faster. When what where does that even start? Like it start by looking. It start from looking at the ending point. It's looking at the ending point right there at the start. This part, this part X. What? This should like minus the X, right? How about if we like rotate it like that, 180 degree? Oh. Wait, what? Huh? Huh? Oh, position is not the same as the frame. So we the every part always have a front part. Oh, so this is the front part, not the position that is minus, but we need to know where is the front part of a part. How do we know if a part is the face? Like I understand now. I understand now. Like this front part, this is it should be on the X, and the front part is this one. Can I make like color or decal? Oh yeah, decal. Oh yeah, the decal is on the. We can make it the face on the front. Oh yes. Name is decal. You can make the color into like orange or something. I don't know what decal is even. It's easier. Okay, so what I know is that is the front face. So it looks to the front and then it looks to here. So it's looking each other. Looks first and then now it looks there. Okay. So I can make like cinematic where I can see my own character, right? Right, right, right here. I can move it here. I can move it here. Then I can like rotate it right there. So I can see my own character there. Look at here. Look at down like that. Okay. Let's see. Let's see. Oh, wait. I need to encore the part. Ooh. Wah. Wah. Ah. That's cool. Okay.
sort of transition with camera manipulation and tween service. Now, there's two rendering properties I want to show you that you might find useful. But before we do, I'm going to disable our local script and I'm going to select the camera. So there's two properties I want to show. Transition with camera manipulation and tween service. Now, there's two rendering properties I want to show you that you might find useful. But before we do, I'm going to disable our local script and I'm going to select the camera. So there's two properties I want to show. The first one is focus, and the second one is field of view. Field of view is a property I find useful. But before we do, I'm going to disable our local script and I'm going to select the camera. So there's two properties I want to show. The first one is focus, and the second one is field of view. Field of view is a property that essentially tells us the extent to which we can see the world through our screen. And basically what I mean is, if we change this field of view from 70 to, let's say, 100 by increasing it, then it's going to compress the screen vertically so that it feels like we can see more of the world than we can actually see. And if we do the opposite by changing this to something smaller, like 40, then it's going to expand the screen vertically outward so that it feels like we're zoomed in and we can actually see something that's closer. So a smaller FOV would be useful if, let's say, we wanted to zoom in on something, and then a bigger FOV would be cool for something like if the user has like a shift sprint system and we want the player to see that they are moving faster by changing the FOV to something where we can see more of the world. So that's basically what FOV is. I'm going to set this back to 70. And the other property is called focus, which is essentially a point in the world where we want Roblox's graphical system to prioritize anything it needs to render within this specific focus point. Property is called focus, which is essentially a point in the world where we want Roblox's graphical system to prioritize anything it needs to render within this specific focus point versus anything that's farther away from this focus point. Now, by default, you don't really have to worry about this property because as you can see, while I'm moving my camera, the focus is being updated with the C frame of the camera. And usually the focus property is synonymous with the C frame camera because when we have the camera subject be set to, let's say, the player's humanoid, then the focus point is going to be on the character's humanoid. But if we, let's say, had a customized system where we have a scriptable camera type, we would have to change this focus property manually. And because this is being updated every single frame, we would have to use run service to update the focus every single frame when we're using our own scriptable camera type. And that's something I want to introduce to you that you might want to consider using inside the future. Okay, so now I'm going to show you what are called raycast methods and how they have a scriptable camera type. We would have to change this focus property manually. And because this is being updated every single frame, we would have to use run service to update the focus every single frame when we're using our own scriptable camera type. And that's something I want to introduce to you that you might want to consider using inside the future. Okay, so now I'm going to show you what are called raycast methods and how they apply with the camera. Now, I haven't made
What is focus? Focus, a C-frame representing the point the camera is looking at. Oh, help the engine prioritize rendering details around that point. Okay.
a dedicated tutorial on raycasting yet, so whatever I talk about in this episode, I'm going to be omitting the technical details of the raycasting part. But I still want to show some methods that are very useful with the camera that I think you want to use in your game. And one of those methods is called get parts obscuring target. Now, basically what this method does is we take a specific point inside the game and we want to detect if there's any instances that are blocking that position inside the game. So let's say we take this spawn location right here and we want to get the position of this. So with the position of the spawn location, we want to check if there's any parts that are blocking it from the camera. But as of right now, we can see the spawn location. But if we were to hide behind this wall right here, then this is going to be a part that is obscuring this spawn location's position. So we can do that through our script using this camera method. And so that's what I'm going to show you how to add right now. So what we're going to do is go to our little script. We're going to drop two lines. Well, actually, first thing we're going to do is we're going to comment out everything we've had up until. Okay, so now I'm going to show you what are called raycast methods and how they apply with the camera. Now, I haven't made a dedicated tutorial on raycasting yet, so whatever I talk about in this episode, I'm going to be omitting the technical details of the raycasting part. But I still want to show some methods that are very useful with the camera that I think you want to use in your game. And one of those methods is called get parts obscuring target. Now, basically what this method does is we take a specific point inside the game and we want to detect if there's any instances that are blocking that position inside the game. So let's say we take this spawn location right here and we want to get the position of this. So with the position of the spawn location, we want to check if there's any parts that are blocking it from the camera. But as of right now, we can see the spawn location. But if we were to hide behind this wall right here, then this is going to be a part that is obscuring this spawn location's position. So we can do that through our script using this camera method. And so that's what I'm going to show you how to add right now. So what we're going to do is go to our little script. We're going to drop two lines. Well, actually, first thing we're going to do is we're going to comment out everything we had up until this point, and also going to
With this, I can make like if I cannot see, if the monster can see, if I I can already see that if I see the monster, then it stops. Oh, I think I know how to make that.
comment out this task about statement at the beginning. But we're going to keep the camera reference. So here's what we're going to do. We're going to say local parts obscuring target equals camera colon get parts obscuring target open close parentheses. And inside of here, it takes takes two parameters. One of them is cast points, and the other one is an ignore list. So I'm going to explain what both of these are. So cast points is basically a table full of these vector 3 positions that I was mentioning earlier before with the spawn location. Now you can have more than one position if you want, but I'm going to say for the sake of this example, this spawn location position right here. So what we're going to do is drop a line at the beginning, and we're going to say local cast points equals game.workspace wait for child spawn location, and then we're going to wrap this with curly brackets to make this a table. So this is our cast points, and we can pass this in as the first parameter. So we're going to say cast points just like this. And now the second thing is an ignore list. An ignore list is basically a table full of instances that we don't want to include for when we're detecting if there's the parts that's obscuring the cast point position that we're interested in. So let's say for this part right here, if we add this to the ignore list, then we can still see this part's location because we added this to the ignore list. So we can do that in a little script by saying local ignore list equals open close curly braces, and we can add that inside of our second argument just like this. Now there is going to be a problem with this ignore list. So now what I'm going to do is I want to be able to demonstrate this inside of Roblox Studio, and the best way we can do this is by using run service so that we can get a frame by frame representation inside the output. So here's what we're going to do. We're going to say local run service
Oh, there is nothing in the ignore list. Okay.
equals game get service run service just like this. And what I'm going to do is say run service dot heartbeat connect function open close parentheses enter, and I'm going to take this line and paste it inside here. Now, what I'm going to do is check if the number of instances that we get that are obscuring the target is greater than 0. So that tells us if there's at least one part that's blocking our target. So we're going to say if. Now, what I'm going to do is check if the number of instances that we get that are obscuring the target is greater than 0. So that tells us if there's at least one part that's blocking our target. So we're going to say if pound symbol parts obscuring target is greater than 0. Then we're going to print something is blocking the target. And then what I'm going to do is print out all the parts that are blocking the target. So we're going to say for I, comma, part in I pairs, open close parentheses. Parts obscuring target do, and then we're going to print the part itself. And then to separate every single time we check this, we're just going to separate this using a couple dashes. Okay. So here's what we have so far. Let's go to the game and hit play. Now there's going to be a problem with this. So right now, oh hold on, the script is not working. Oh my bad, there's a typo on my end. So we're supposed to say
Yeah, that actually shocked me, my guy.
spawn location dot position because this is a table full of vector 3 values. We're not
Oh, cast point is position.
putting in the instance themselves. So now if we go to the game and hit play, there should be a problem here. And I'm going to show you why. So it says in the output that there is something that's blocking the target, which is the spawn location itself. That's because for the cast points, we're interested in the position of the spawn location, not the spawn location itself. So what we need to do is add the spawn location to the ignore list vector 3 values. We're not putting in the instance themselves. So now if we go to the game and hit play, there should be a problem here. And I'm going to show you why. So it says in the output that there is something that's blocking the target, which is the spawn location itself. That's because for the cast points, we're interested in the position of the spawn location, not the spawn location itself. So what we need to do is add the spawn location to the ignore list so that it's not counted when we are looking for parts that are obscuring it. So I'm just going to copy this line here and I'm going to paste it inside the ignore list. And now what we're going to do is add the spawn location to the ignore list so that it's not counted when we are looking for parts that are obscuring it. So I'm just going to copy this line here and I'm going to paste it the ignore list, and now what we're going to do is hit play. So the spawn location should not be included with any part that's obscuring it. So now if we look at what's happening here, what I'm going to do is block the spawn location using this part. And so now I'm going to say that something is blocking the target, which is this part right here. I can even stand in front of it, and there's going to be a bunch of hats and accessories from my avatar that's blocking this spawn location as well, and it's being displayed in the output here every single frame. And so this is essentially what this function does. And you can definitely find usefulness with this function. So this is something I want to introduce to you that you might want to use for your games. Okay, the next method I want to show you is called
I need to think. Oh, the local script is disabled. Okay. Okay, bro. Oh, okay. Block and oh, oh, okay. I understand. I understand. Get part obscuring. Get part obscuring target to fire an event when something is obscuring the view of the hash point. So the cache point is position.
World 2 screen point. Now, the idea behind this method is that we want to take usefulness with this function. So this is something I want to introduce to you that you might want to use for your games. Okay, the next method I want to show you is
I already know. Like for example, right? If we are playing, for example, like through a first person play, right? So if we make it like this, right? Now nothing is blocking. Oh, the handle itself is blocking the view. Okay, okay, just for example, okay? Now the handle is blocking the view. But now, boom, we cannot see if there is a ghost here. Then we cannot see the ghost. Then the ghost can move. But if we check, boom, the ghost will stop. So it will keep following me if it doesn't. It will keep following me if I don't see it. I can how I wanna try to make something that first of all, okay, I'll try to make something with this, okay. Now I need to stop the game first. Need to know how to make my camera to be first person view. So I make a function, right? I make a function. Okay, starter player scripts. Make a local script here. So what do I do is like we make a function. Why is this? Player equals to game.players.local player. If enabled, then player.camera max zoom distance equals 0.5. Player.camera min zoom distance equals 0.5. Else, we set it to default 128. So I just simply run it, right? Set first person true. Yeah, let's try. Okay. Wait, I'm thinking. Like if I don't see the thing, it will chase me. But if I see the thing, then it will not chase me. Uh, how can I make that? Hmm. Okay. I want to make. Okay, let me think first. Okay. So if I play, right, forget the handle. Like now, the thing can chase me, right? If I look at the thing, oh, there must be something. There must be something that is like when we can see a thing, then it will fire the event. I think there is something like that. There should be something like that. Wait, how can I like go out from this? Oh, okay. Hmm. Okay, I'll do that later.
It's called World 2 Screen Point. Now, the idea behind this method is that we want to take a vector 3 position of whatever part that's inside the game, and we want to convert that to a 2D position or a vector 2 value that's going to be displayed on our screen. That's relative to the camera as well. So let's say we had this part that's right over here, and we wanted to take that vector 3 position of this part and convert it to a screen position that's going to be displayed on our screen. So that's essentially what this function is going to do. Now, instead of coding this up, I'm going to show you a really practical example of this so that you get an idea of what I'm talking about. Okay, so this video demonstrates what I'm talking about. And essentially what's happening here is that there's all these coins that are scattered across the map, and when the player picks up the coin, then it's going to convert the vector 3 position of that coin and give us a 2D position of that part that's on our screen that's relative to the camera. And it's going to create this image label of a coin and display it at that position. And then it's just going to fly off to the screen once it's done. But this is essentially what I'm talking about when it comes to converting a 3D point and converting it to a 2D point on the screen. And this is a really practical example of using this function, which I'm going to give credit to my admin for creating this and also for creating the script as well. So essentially World 2 Screen Point takes one parameter, which is the position of the coin that was being picked up, and then it returns a vector that gives us the x and y components of the 2D screen. And this is a boolean that tells us whether this actually fits on the screen or not. And then it creates the coin image label and shows it on screen. So then as you can see, we take a uint2 value and we use the vector's x and y component to change the position of the image label for the 2D screen. So this is a little practical example I want to show. I hope that this gave you insight into using this function. Now there is another method called World 2 Viewport Frame.
Oh, so when something touch something, then it will convert to a number. Oh, that is like from an incremental game that I play.
But this is
Okay.
literally the same exact method as World 2 screen point, but there's only one difference, and that is we're not taking into account the GUI inset that is built into every single Roblox game, unless the developer specifies not having this GUI inset. And what I mean by this GUI inset is that Roblox reserves a specific amount of space on the top of the screen for their own customized UI, like these buttons over here. And so with this function over here, we're essentially ignoring this top part here when we're using World 2 viewport frame. So that's the only difference, and I think it's a pretty nice distinction from the two functions. So depending on which one you use, I hope you find practical use with these functions, and I hope you found
Wall to screen point. Oh. Wall to screen point. Dang, my brain. Get parts obscuring. Mastering camera is like a whole another level. Like camera, wall to screen point. Okay, let's try something. Okay, so we can use it. Like, so I want. Okay, so let's make a part. Like the video make a part that if we touch something, then that part is gone. It is destroyed, and then it shows up into coin. Let's make it show up into coin, like into a like GUI or something. So to do that, I think we simply just first of all, let's like stop all of this first. Okay, let's make it like from the first. Okay, local script. So first of all, local camera equals to game.workspace dot current camera. Wait, what does that even mean? How to use world to screen point? What is world to screen point? The function is called on the camera object. It returns two things. Screen point, it is a vector tree. Is on screen. And the true false telling if that point is actually visible on player screen or if it's behind that camera. So let's make a target part, okay? Let's make a target part. Let's make a part. Let's call this target part. Let's make the target part into like yellow. Okay, this is the target part. And then let's make a reference to it. Target part equals game.workspace. Wait for child target part. Okay. Local screen point equals to screen point and on screen equals to camera wall to screen point which is a target part dot position. Okay, so let's try to print it and let's see what it shows. Screen point and on screen. Screen point. What do you call table value? Dang, man. Let's just do this. Screen point. Rain on screen. Between that, let's print a. This is true. On screen is. Oh, oh, oh. I think I understand. I think I understand. Let me make it on the. If on screen. Instead using billboard UI, so it's going to be like if you have 100, many pros use single screen UI and use word to position UI labels over player heads every frame. Use in game where a little press E button follows a door or an item, that is usually UI element being positioned via this function. Hmm. Oh, in a round system, if you want to show a target icon on the screen where the objective is, you use this to find the X and Y coordinate. Okay, there is a tiny variable using this too. There is viewport and yeah, there is to viewport. Ignore the viewport, ignore the Roblox top bar, and work to screen point accounts for the top bar. Script that make UI frame follow apart in the world. Um, hmm, okay. So let's not make something too hard first, okay? This is the target part, okay? Now we make this onto the render step, for example, like run service, local run service equals to, okay. We have the camera, we have the target part, and then let's try to make like a frame here. Let's try to make a frame here. Wait, why? Run service, render step, dot connect function. There is the delta time. Okay. Okay. If it is on screen, then it will like print. That is on screen, yeah. But something is blocking the view. It blocks the view. It is always on screen. What? Hmm. Port to screen point. It takes 3D position and tell you where exactly that point will be on 2D monitor. Or if it's behind them on screen boolean. A true or false value telling if that point is actually visible on the player screen. It is a target part, right? I cannot even see the target part. But how does it work? Like, oh, the false and the true. Oh, if it's blocking the view, then it's false. Oh, okay. Let's make the on screen to false if it blocks the view using the I already forgot to get part obscuring target. How to make get part obscuring target? There is a cast point and ignore list. We ignore the item itself, but the cast point is the item. And then if part obscuring, hmm, so if the part obscuring target is more than one, then it will be false. So let's make it like local part obscuring camera dot get part obscuring target. Now we have the cast point. The cast point is the target part dot position, and then the ignore list should be like the target part itself. And then if wait, how to make like the on screen is to show that on screen is still true when a part is blocking them. Why is that? The on-screen boolean word to screen only cares about camera field of view. On screen is true if 3D point inside imaginary pyramid the camera can see. It doesn't care if there is a wall, mountain, yeah. On screen false only the point behind the camera or off to the side. How to detect if a point is actually visible? To check if a part is blocking the view, you need to use ray casting or the function you already have in your core get parts obscuring target. In your current scheme, you are calculating the obscuring part, but you aren't doing anything with information. Yeah, that's true. On screen remains true. How do I check the visibility? You must combine on screen with an occlusion check. Okay, if on screen, okay, let's try this like if on screen. We need to check that if on screen, then we need to check if the local path obscuring target, this is like the blocking part, right? That's the blocking part. So there might be more than one blocking part. So blocking parts obscuring target. Mm, So we ignore the target part and we ignore the player dot character. Oh, we also ignore the player target part and also the player dot character. I see. Oh, we need to make a player first, like because this is a local script, we can just make a player. Local players equals not players, the local player. And then if the table is empty, like if on screen, right? If blocking parts, equals to 0, then print target spotted, else print target not spotted. Something blocking the screen. If not on screen, then else we print something blocking the screen. Um, Target not on POV. Target spotted. Target spotted. Target spotted. Target not on POV. Target something. Ooh, my god. Oh. This is it. Wait, will I use render step or heartbeat for this one? The rule of time of script is follow the camera. The quick answer: use render step if you are updating UI and camera position. Use heartbeat for everything else like physics. Fires before the frame actually drawn. Removing UI element to flow part. You want this moment to happen exact time as the camera moves. If you heartbeat, UI will often feel like it's lagging behind or vibrating. If your code inside render step takes too long to run, you will actually lower the player FPS. Finish. Heartbeat is much safer because it doesn't block. Checking if a part visible, here's how it should be structured to be visible. We do a heavy visibility check on heartbeat, so we don't lag the FPS. Oh, I see, I see. So to make it so it doesn't lag. So what I need to do is, so I make like, oh, okay. So I make it like local is visible equals false, right? And then I make run service dot heartbeat, like the heartbeat connect function, and the function is local screen point. We make this local screen point is on screen. All right. If on screen, let's make this like here, all of this here. If on screen, then the local blocking part, yes. Um, mm, local blocking is camera visible, like this is the hardware position. We don't see the character and the target itself. If on screen, Oh, there is a cool way to write that, my guy. So if on screen, then local blocking part is that, okay? Is have an end. So we make it so like is visible equals to blocking equals 0. Oh, the blocking part equals 0. If the blocking part is 0, then it is visible. Else, is visible equals false. Okay. And then the render step, if it's visible, then we still need this, right? Oh, we only need the on screen here. Oh, local target position first camera dot. Oh, we don't need this if it's the first one. If it's the first one, like on screen is like the true, right? If visible, local target position, like no, this is the screen point. The screen point. We just need the screen point equals to the position. Let's make a UI. Let's make a UI, okay? And the U frame, the frame, let's make like a text label. Where do I put the UI frame? Starter GUI, and there's a screen GUI. Frame inside. Hmm. Screen GUI properties usage. If the script is inside the frame, UI frame equals script.parent, screen GUI equals UI frame.parent. Wait, what the hell is that? This is the frame, right? So this is like the part I wait, let's make it functional first, okay? Okay. So this is a screen GUI. The script is in the starter player script. This local script. That's okay, our game organized like this should go the local player hierarchy. This option one inside the frame is the easiest. The pro standard. If the script is only corresponding the if you plan on having many different markers or quest NPC shop, you put one controller script here. The pet starter player scripts, local script. Yeah, that's true. So I think up the variables name correctly. If you put a script inside the frame, no, I don't want to break it inside the frame. Here's to write it so it never breaks. If frame important, avoid the infinity. If you reward space target part. If your player join a game and that part hasn't spawned, got it. Always check if the target exists before trying to get its position. Oh, so the local script, like I have the camera, I have the player, I have the target part, I have the run surface. Now I need the UI frame. Local UI frame. I know this is like kind of messy, but it's fine. Local UI frame equals game dot get surface. No. What the hell? The local frame is inside the starter GUI. So make it so that is there a get surface for like starter GUI? Oh, there is. But I don't need that. Like let's make it game dot workspace dot no. The game dot starter GUI dot screen GUI dot frame. UI frame is this one, right? So now to make the math work perfectly with screen, you need to change these properties on the UI frame. The anchor point 0.5 0.5 by default. So wait, let me do it later. So if it's visible, okay. So if it's visible, then local script point we have the target position. So UI frame dot visible equals true. Else UI frame dot position equals true udim2 udim2 dot from offset returns a new udim2 with a given offset component and no scaling. I don't understand what that is like. But let's just use it. So this screen point dot x. Can you do that? What the hell? Screen point dot y. What the hell is a screen point even? Oh, there is a XYZ. I see. In other words, else frame visible equals false. So first I need to make the screen GUI to false then. So the screen UI, the visible is false. Hmm. Oh. Oh, the screen UI is visible. I'm stupid. Enable visible. Wait, what? Um, no, it's the frame, right? The frame to be visible on the starter GUI. Yeah, it's visible. It is on the starter GUI. It's here. If I play start, it's visible. Okay, it's visible. Um, let's print it, man. So if visible, print visible. If not visible, print not visible. See if it works. Okay, it works. So this is printed. UI frame is game.starterGUI.screenGUI.frame. If it's visible, then UI frame dot visible was true. If it's not visible, then it becomes false. We already know this that this works. The is visible is always updated. So if we can see it, then it is visible. We cannot see it, it should be not visible. Doesn't work. If it's not visible, it's still there. To make the manual, you need to change. Okay, let's see. Um, you're talking to the blueprint of the building in fun. Trap if into. In Roblox, starter GUI is just storage folder. When a player joins, everything in starter GUI is cloned into player own profile folder. Oh, if you change a property in starter GUI, nothing happens on your screen because you're editing original copy sitting on the server storage. You need to edit the copy that is currently inside the player GUI. Oh, dang man. Player GUI equals to player. Wait for child. Player GUI. Frame. UI frame equals to player dot wait for child Wait for child target part. So this is, oh, no, this is the frame. The frame. Um, it was changing. It was working, but only on the invisible original copy. When you stop on the screen, if you put the script inside the frame, you don't even need to tap the long pad here. Hmm. Now the UI frame is the UI frame inside the, but it still doesn't work. Player equals game.players.local player. Let's make the surface all into the top, okay? There is only run surface, right? Then camera is current camera. I just make it like workspace. The hell is workspace even? Current camera player is when player target part is target part. Player UI. Okay, UI frame. Okay, it's not even printing anything. It's not even printing anything. Something is wrong here. Wait. UI frame is visible equals false. UI frame visible, the print visible. If is visible, yeah, this is the local script. Okay, it's not even printing. Something is broken. Something is broken. Infinitely possible on screen UI. Oh, we need to make sure the screen UI. We need to wait for everything to load first. Wait for child the target part. Target here camera. This is player UI. Screen UI. There is a screen UI inside. Oh, it's player UI. Oh yeah, it's player UI. It's player UI. All right. Why the screen UI doesn't player UI? UI screen UI call player screen UI. Finding UI frame once at the top on the script. Find it inside the loop. Or better yet, put the script inside the frame itself. I'm stupid. What is an anchor point? Oh, that is the anchor point. I see it's on the middle. With properties and be like this, and then ignore GUI insert. Okay. That was really, really hard, man. It's like make a text label inside the frame. No background color. Oh, let's make a background transparency to 1, and then the label simply to just match that. Then make the label text into text scale. Yeah, yellow block. Get bigger. Yes. Is the size always the same? Yeah, the size is always the same. It took me so long to make this thing, man. So tired. Render step heartbeat. Okay. I think that's it, guys. I think that's it. Frame or in Either put in the frame or in the starter player scripts. For this specific, for a single UI, man, why it's better the self-contained rule? In professional coding, we like modules. If you want to move the masker to different game, just drag the frame to the new game. The script goes with it, and it just works. We don't need to deal with wait for child. Just type script.parent. If you call UI frame.destroy the script inside, it stops automatically. It will keep running in the background trying to frame a frame that doesn't exist anymore. Oh, when you should use starter player script instead. Use starter player script. Use starter player script when you're building a global controller. If your game has 100 different items that all need markers, you do not have scripts running. That will be laggy. Instead, you will put one script in starter player script. Use a for loop to find every item that needs a marker. Update them all from that one single script. Hmm. Your explorer this frame local script. Let's move to phase one. So I can put the script in the frame like this, and then I can make like local UI frame equals script parent. Damn, okay.
Found this part to be informative. So for today's challenge, I want you to create this spectate mode GUI system where we have a button here that says spectate, and if we click on it, then it's going to show this little panel here that displays what player we're currently spectating, and we can click these arrows to flip to different players' perspectives so we can spectate them. So if I press this right button, then it's going to change the camera to reflect on this player's humanoid instead of my humanoid. And then if I were to flip it back to my character, then it's going to change the camera to reflect my character's humanoid. And we can do the same thing going reverse, and we can do the same thing going forward. So this is what I want you to create for this challenge. And for the sake of time, so once you've given this a try, then we can come back and dive deeper into this spectate mode GUI. So for the sake of time, I'm not going to be coding this with you step by step, but I will show you what I did with my code so that hopefully it can give you a better understanding of how the system works. So what we have here on the right side is a spectator screen UI. So if I open this, then there's going to be a local script, a frame, and a button. So the spectate button is the button down here, and
Yeah, let me see.
what player
What we need.
informative. So for today's challenge, I want you to create this spectate mode GUI system where we have a button here that says spectate, and if we click on it, then it's going to show this little panel here that displays what player we're currently spectating. And we can click these arrows to flip to different players' perspectives so we can spectate them. So if I press this right button, then it's going to change the camera to reflect on this player's humanoid.
Oh no! After I make this, I need to. Spectate. Ah.
Instead of my humanoid. And then if I were to flip it back to my character, then it's going to change the camera to reflect my character's humanoid. And so we can do the same thing going reverse, and we can do the same thing going forward. So this is what I want you to create for this challenge. And for the sake of time, so once you've given this a try, then we can come back and dive deeper into this spectate mode GUI. So for the sake of time, I'm not going to be coding this with you step by step, but I will show you what I did with my code so that hopefully it can give you a better understanding of how the system works. So what we have here on the right side is a spectator screen UI. So if I open this, then there's going to be a local script, a frame, and a button. So the spectate button is the button down here, and the spectate frame is the little panel that shows the
I need to make this, man.
player's name that we're currently spectating, and the left and right button so we can flip through different players. So if I open this up, there's a left button, a right button, and a text label that tells us the player's name that we're currently spectating. So I'm just going to disable this, and now we're going to analyze the local script behind it. So basically what we have going on here is a player list that gives us a table of all the players that we can spectate, and then this position is the index value of the player that we're going to be viewing inside of the spectate mode GUI. And there's two functions here. So the first one is update player list. This one just takes our player list and updates it with all the players that are currently available. And the update camera is what allows us to change the camera subject of our current camera to whatever the player that we're currently spectating is, to whatever player we're currently spectating, and we get a humanoid with that. And then we change the text of the player name with that as well. Okay, so once we press the spectate button, so this one down here, then it's going to update the player list automatically. And it's going to give a check as to whether we are currently spectating, and if we are, then we're going to set that equal to true. We're going to set that equal to false, and if we are, then we're going to set that equal to false. And if we are, then we're going to set that equal to true. And if we are, then we're going to set that equal to false. And if we are, then we're going to set that equal to true. And if we are, then we're going to set that equal to false. And if we are, then we're going to set that equal to true. And if we are, then we're going to set that equal to false. And if we are, then we're going to set that equal to true. And if we are, then we're going to set that equal to false. And if we are, then we're going to set that equal to true. And if we are, then we're going to set that equal to false. And if we are, then we're going to set that equal to true. And if we are, then we're going to set that equal to false. And if we are, then we're going to set that equal to true. And if we are, then we're going to set that equal to false. And if we are, then we're going to set that equal to true. And if we are, then we're going to set that equal to false. And if we are, then we're going to set that equal to true. And if we are to make the frame visible. And we're also, just as a safety measure, we're going to make the character not be able to move while we're spectating. And we're going to set the position automatically to 1. And then we're going to use update camera with the player that lies in the position of 1. And if we're not spectating, then we're just going to let the player move. We're going to disable the frame, and we're going to let the player have control again since we're not spectating anyone. Okay, so that is what happens when we press the spectate button. So if we press the right button, so if I were to load up the frame again, it's this button right here. It's going to check whether we're spectating, and if we're not, then it's just going to return the function. We're going to update the player list again, and then essentially what's happening here is that we're going to be updating the position before we update our player's camera to that position inside the player list. So essentially what's happening here is that if this increment is greater than the size of the player list, then we're going to be going out of bounds, and we don't want to do that. So what we do is we set the position back to 1, so we're essentially resetting it. And if we're not going out of bounds, then we're just going to simply take the position and add 1 to it. So we're flipping through the players of the player list. And so that's what we do when we take the camera. And we're essentially doing the same thing with the left button where we press it, except this time, instead of going forward, we're going backwards. So we're going to take the position and we're going to subtract by 1. And we're going to see if this is less than 1, because if we have a value of 0, well, there's no such thing as an index value 0, so this is not going to work. So if this is the case, then we're going to set the position to the size of the playlist. So we're going to start backwards. And if that's not the case, then we're just simply going to decrement the position by subtracting it by 1. And then once again, we're going to be updating the camera. And that is essentially the rundown of this spectate GUI script. And I hope that this explanation has helped you with understanding how the system is created. So that's pretty much going to be it for this episode. If you found this video to be very helpful, then I encourage you to leave a like on this video. It's true. We're going to make the frame visible.
So the important part is the update camera. What is camera subject even, man?
Functions here. So the first, the player's name that we're currently spectating. So I'm just going to disable this, and now we're going to analyze the local script behind it. So basically what we have going on here is a player list that gives us a table of all the players that we can spectate, and then this position is the index value of the player that we're going to be viewing inside of the spectate mode GUI. And there's 2 functions here. So the first one is update player list. This one just takes our player list and updates it with all the players that are currently available. And then update camera is what allows us to change the camera subject of our current camera to whatever the player that we're currently spectating is.
Okay, let's just make it to ourselves, okay? Not spectate. Let's just, if we spectate, then we spectate ourselves. That's it. That's easy. That's as easy as that. Now that this is on the local script inside the frame, it's fine. It's there. It's working good. Nothing can stop me. And then the next one, I'll make another GUI, okay? I'll make another GUI called spectate. Then in this GUI, okay, and then in this GUI, let's make a button. Let's make a like text button. And then in this text button, do we always need like the frame first? Do we always need the frame first before putting the... In short, no, you don't need frame. Or putting it inside a group, it will move the group. Oh, I see. So I don't need to do that yet. So I can make the text into text scale. Yes, and then I'll make the text into spectate. That's simple, okay? Don't need to change anything. Yeah, we can just change the color, for example, like to green or something. It's fine. Then when I click it, it should, like on the spectate, right? We can make a like script here, the local script. And then what we can make here, first make a camera, local camera equals to game.workspace.current camera. And then
And update camera going to be viewing inside of the spectate
right? And then local text button equals to script.ui.text button. And then no, let's not make that. Let's make it so player equals to game.players dot local player. Okay. No, local player, yeah. And then we make a function, right? A function spectate equals to local function spectate. What we do is like humanoid or best part that is the camera subject equals to oh oh so so this make the subject camera subject is okay okay humanoid camera subject is that, right? And then yeah, I think just that, man. And then we make it so that like expected the text button. Let's make it like expected button dot mouse button one click, or let's just use activated connect um, function activated. It is activated by the input object, like we can like nah, let's make it later.
Mode camera with clarity as well. Okay, so
Do like uh print a where it prints it is we need to make the camera. We need to make the camera so that the camera is um camera type is scriptable. Camera game dot workspace dot hey, no, camera dot camera type equals camera scriptable. Okay, after we make it scriptable, what do we do? We do nothing. Okay, let's see if this works now. Like, for example, oh, expected. Then we make the camera scriptable. player is me, right? Local player is me, myself, right? Why doesn't it change? If we spectate, if we click it, then we make a camera type scriptable, and then we make the camera subject to the humanoid. Oh, this is click. This is activated. Camera no camera type. How do I make? Hmm. Oh, it is to spectate myself. I don't want to view this, so let's make it like local character. Let's just do this like spectate radio function, right? Let's make like First with toggle first. Yes. Yeah, I know it works. I know it works. This is taking so long, but I know it works. Can I make so I can only see? To make it so I can only see. Oh, face is like the same. So I made like humanoid. Can I make the camera subject to a part like local target part? Wait, no. Ooh, mhm. Okay, I think that's it, man. I still need to make. There is a lot of thing to learn. I think that's it for today's guys. That's it for today. I spent a lot of time on this, man. I still have lighting manipulation, pet finding, raycasting. But it's fine. I'll see you guys tomorrow. Bye bye. Or maybe I'll keep learning, right? Because I don't have anything to do. If I'm gonna stop, I'm gonna eat and then I'm gonna play games. Maybe I'll like continue learning because I got like not so much thing to do. Bye bye. Camera manipulation done. Bye bye.